First of all, let me thank the organizers, ISPA here, for giving me this opportunity to be able to talk to you and tell us our point of view, what exactly we see as how climate change is affecting agriculture in South Asia. So thanks a lot, Paul and others. I am going to talk to you in next few minutes. I think the time given is almost an hour. I am not too sure if I have that much material to talk to you, but we can have lots of Q&A, hopefully. So how exactly we can adapt agriculture in South Asian countries to climate change and declining resources. That's the topic that I shall be talking about. But a little bit that I represent here, a CGIR research program on climate change, agriculture, and food security. And I'm hosted here by International Water Management Institute and New Delhi office. My colleague Priyani from International Water Management Institute is also here. So quickly, we'll move. Perhaps I can just do it. Okay, while that is being set, so let me just quickly tell you what is CCAPS. CCAPS is a partnership between CGIR. CGIR, as far as many of you know, is a global consortium of research organizations. There are 15 research organizations spread all over the world. 80 governments support us, and plus many international organizations support us. Together with FutureArk, which is an organization of many advanced research organizations in the Western world, including ICSO, Belmont Forum, and so on and so forth, plus NARS and National Method Institute. So practically whosoever is one way or other connected with climate change research is in this partnership. So this is a partnership which we started 5 years ago, and with these two specific objectives. First is identify and develop pro-poor. So that's what we always try to underline, pro-poor, adaptation and mitigation practices, technologies, and policies for agriculture and food systems. That's our major goal with which we set up this partnership. And also, as you know, climate change is a big issue globally, political, economic, social, technological issues. So we also endeavor to support the inclusion of agriculture issues in the global climate change negotiations. It has not really been there so far. At all levels, not only at global level, but also national and local scale. So this is what is CCAPS about. Let me move on to my presentation now. So do we have that remote now? Or can I bring it there? No? Okay, never mind. No, that's okay. So, South Asia, as we all understand, this part of the world where we all are here, is about more than 1.6 billion people, almost 23% or 24% of the world population today. So that's what we are talking about. This has still a reasonably higher rate of growth compared to many other regions of the world, although of course in recent times the population growth is coming down. The region, despite being relatively poor, has made considerable progress in the last 4 decades. Average growth rate Okay, thanks very much. Okay. I was saying that we have made tremendous progress. So average, several indicators you can measure. So food consumption, for example, is today close to 2,500 kilocalories. So we have made tremendous progress in terms of that. Average GDP growth is close to 5 to 7% these days, depending on the country, but overall still significant growth rate. And relatively little food imports compared to the 2 decades or 3 decades ago where we were importing a lot of food in South Asia. Despite all this progress, what is ironical is that we still have a huge population of world's hungry. Almost 1/6 of the world's hungry are here, but we have made tremendous progress in this, as you see from these graphs on the right-hand side. These are the Global Hunger Index developed by International Food Policy Research Institute. I'm sorry, there's a small print here. The first one is 1990. So you see all those red areas. South Asia was typically red, so very food insecure. Global Hunger Index was really high. But if you see, this is the latest figure which has just been released in 2014. You see much of the red has disappeared from South Asia. It still remains alarming, but it's not that alarming as it was. So despite that, in terms of the absolute number, it's still a large number. Almost 300 million people are still here hungry. We have largest share of the world's malnourished children and women in general. By and large, we lag in lots of Millennium Development Goals. Agriculture, despite our progress, despite the contribution of agriculture declining in overall GDP, it's about 15 to 20% now in this part of the world, again depending upon the country. But still, the ironical situation is more than 50% population, despite that, remains dependent on agriculture. And it is projected to be one of the key vulnerable regions for climatic risk. All studies point out that. So this is the context, this is the region that we're talking about. Okay, it works now, thank you. So this is one side. On the other side, what we see, this is a region which is very prone to climatic stresses. It's something that in this region we have known for ages. For example, droughts, there have been more than 26 significant droughts in the last 100, 150 years. 70% of land in South Asia is drought prone, one way or other. 12% to flood prone, 8% to cyclone. Frost is very common in northern region. Heat is very frequent episodes at many places, especially in northern part of South Asia, and frequent floods and cyclones practically in several regions. So one or the other climatic stress is something that is experienced by all regions of South Asia. But this is historically has always been there. What climate change is trying to do is to accelerate the pace of these things, increase the frequency of many of these climatic stress events. That's what is happening these days. Okay, at the same time, what we also see, land degradation. If we look at this graph, there are several parts of South Asia which have one or the other form of land degradation. And what has also happened over the last 40, 50 years, ever since we started doing modern agriculture, pace of some of this land degradation has increased. Not only because of agriculture alone, but also because of overall urban development and other factors as well. So there is critical elements, especially of water erosion. You will see lots of area affected by overexploitation of groundwater, especially again in northern parts of India and Pakistan. Also we see in Bangladesh that is also becoming common. And similarly other forms of land degradation are there. So several studies point out that climate change that we are talking about, that's the focus of our discussion today, brings an additional stress on already so many stresses that the region faces: population, low literacy, poverty, climatic stresses. Climate change brings an additional stress to the region. So this is a classical study that we often use to show that how exactly South Asia is a major hotspot. All reds and blues are the regions which are most vulnerable in this graph. So you see much of South Asia here, especially the northern part of South Asia, the whole Indo-Gangetic plain spanning across Pakistan, India, Nepal, Bangladesh. These are the regions which are very, very vulnerable to climate change. High exposure and low coping capacity of many of these regions. Similarly, several regions of Sub-Saharan Africa are also hotspots. Okay, so what is that this region is trying to do in order to understand what are the impacts of climate change, what are likely impacts of climate change, and how shall we prepare ourselves? So this is, I just wanted to show you here So there are state-of-art facilities available in this region. In fact, if you go 20 kilometers from here, and if some of you are interested, you can visit that. There are very sort of state-of-art facilities to study climate change impact or climatic impacts on agriculture. For example, here in this slide, this pointer, this is the pointer, middle one. Okay, thanks. So you have typical temperature gradient tunnels where you can regulate temperature from one end to other end and expose plants to changes in temperature as you'd expect in future. These are open top chambers where you can raise carbon dioxide, or temperature, or even ozone to understand how plants are going to respond. These are what we call phase, free carbon dioxide enrichment facilities, where you can expose plants to higher CO2, a type of CO2 that you expect in future to come, and also a combination of many of these. So these are the facilities, plus there is a lot of modeling environment available here in this part of the world. So many of these studies have led to a very good understanding of what is really climate change going to cause. So what sort of impact climate change is going to cause on agriculture here. So this is a brief summary. I think much of this is already very well known, but just to recapitulate some of the points that we all understand as CO2 goes up, and when we talk about CO2, we are talking about roughly 550 ppm here. It increases yields of most C3 crops globally, but also in South Asia. It's not an exception. It increases yields here as well. But what is also very important for us to understand, that temperature increase, which is part of this whole story, reduces agriculture production by and large depending upon the region. Because most of our parts in South Asia are at a critical threshold. The small increase in temperature generally leads to decrease in agriculture production, except in hilly areas. So as a sort of a thumb rule, we can say if temperature increases by 1 degree, crop yields, depending upon what crop we talk about, yields are reduced up to 7%. And 7% when we say slightly weak. And much higher losses at higher temperature. Something very similar you will note in other tropical areas as well. But what is very important for us to note, that these mean changes are not so critical. Mean changes in temperature, mean changes in rainfall, scientific expertise, or let's say innovations, have been able to adapt to some of these changes. But what is really difficult is this increased production variability due to increasing events and intensity of droughts, floods, and heat events. That's a very significant challenge for all of us. We always like to talk in terms of negative impact, but that's what makes news. But climate change does provide some opportunities as well, even in this part of the world. But these are largely unexplored. We are so much driven by all the negative impacts that we often don't talk about it, but there are some opportunities. I'll come back to this again later. But as many studies, especially IPCC studies, have indicated, this all has large implications for trade. So as I said, it's trade in the sense that we are not importing much food here, but we're exporting a lot of food items from this part of the world these days. So this will have significant implication in case the food production gets reduced, population is still increasing, food demand is increasing because of increasing income. So that will have a lot of consequences of how exactly trade takes place. So this is our current understanding of possible impact of agriculture, of climate change. Okay, what is also very important is for us to understand this fact, which is often not yet documented, is increasing tropospheric ozone concentration. That's another challenge which is often going unnoticed. This concentration is significantly increasing these days because of our increased industrial activity. So what happens, CO2, as we all understand, is a positive impact. So this is, for example, just to illustrate. So at elevated CO2, for example, if it is 7% increase in production, this would have been actually 18% had ozone effects not been there. So ozone is already depressing crop yield. The effect of CO2, the beneficial effect of CO2, which we are banking a lot in future, are likely to get nullified as time progresses and as current development trajectory continues because of increased CO2, or because of increased ozone. However, having said that, we still don't fully understand all the interactions, that how exactly ozone, CO2, temperature, and extremes are going to interact. So that's an area for all of us to invest much more. But the initial results, again, not only from this part of the world, but also globally show that these interactions are going to be very, very significant in time to come, and it's time that we start paying more attention. Okay, so set the context now to the main part, that how do we adapt? Okay, we by now, IPCC, national reports, many other global reports have told us that yes, we are vulnerable, we all understand. Rest we don't understand fully well the magnitude, but we understand that we are all vulnerable. So what do we do? So the point that I'm trying to emphasize here is that when we try to adapt, we are talking of adaptation to future. We shouldn't really see climate change in isolation. There are many other challenges that these regions face. I just mentioned some of them. There's increasing demand for food here, because the population is growing, incomes are growing, so big demand on food and quality of food. What food, so that is also changing. Increased competition for resources. As economies are developing, there's a big competition for land, there's big competition for water, big competition for even labor. It used to be easily available. So we have to see somewhat different environment in time to come. And of course, increasing degradation of resources. I already talked to you a little bit about water resources. Of course, climatic risk is something that we are talking about. But what is also very important for us to appreciate, that variability is also increasing globally, not only increasing here. So a lot of food that we were able to import in, let's say, 20 years ago, may or may not always be available in future. So it's a very challenging environment for the region because of multiple stresses right now. So when we talk about adaptation strategy, we have to talk not only about climate, but also keep in mind that there are many other challenges that we have to address. Okay, so I would like to make 5 key points that we believe should be really useful for us to adapt agriculture to climate change. Okay, the first one is that we are very fortunate in this region that there's a lot of untapped potential here in terms of agriculture. There's a lot of untapped potential, and I think that provides really a lot of opportunities for us in future. Even if we don't develop new technologies, even with current technologies, there's a huge scope for us to capitalize, and we should be able to address many of these challenges in time to come. Just to illustrate, let me also just clarify, a lot of my examples happen to be from India, but you can take it by and large as representative of much of South Asia. So this is an example of wheat and rice potential. So if you look at this green bar, this is what is potential of today's variety. For wheat, we can harvest 6 tons per hectare. Rice, we can harvest up to 8 tons. Of course, in individual fields, you can go even much higher. So these are national aggregates. Even if we consider many other factors, still attainable yield is 4.5 tons and close to 6 tons in rice. What we are harvesting today is only 3 tons of wheat and about 2.5 tons of rice. There's an immense opportunity already available, right? So even if we don't develop, it's not that we are not developing new varieties, we are developing better varieties. Globally, there's a lot of effort on that. But even with current varieties, you see there's a tremendous gap, especially in crops like rice, which still needs to be harvested. Of course, there are a lot of spatial variation in that. Some regions have already sort of exhausted this gap. Some regions, there's still a lot of gaps. So that's something for us to count on. But it's easier said than done. To bridge this yield gap, you require big investment in management of land and water resources. It's not that since you have a yield gap, it will come automatically. It provides you an opportunity, a window of opportunity, but to encash that, you will need to invest in strengthening agriculture systems. The whole value chain has to be strengthened. Not only in managing land and water resources better, but also input delivery and market linkage mechanisms. These are relatively still weak in many parts of South Asia. So that's our first window of opportunity, a ray of hope that yes, we can do a lot. Second one is we really need to understand how do we manage our current climatic risk. And to a large extent, a lot of poverty that we see are in the regions which are more prone to climatic risk. And a lot of inequity that you see are in those regions where climatic risks are big issues. And those risks are increasing because of climate change. So we really need to address that. I also made a point earlier. In climate change, we have to see from two perspectives. One is mean changes in temperature and rainfall. One is this whole variability issue. By and large, scientists have been able to address these issues of mean changes. And there's still a lot of hope with new tools of biotechnology, molecular biology becoming available, that those challenges, slow rise in temperature, 2 degrees over the next 50 years, is something that scientists should be able to address. But what is a big challenge is this day-to-day variability, and that too unpredictable. We are not able to predict very well when is it going to be next drought, when is going to be next heat period, when is going to be flood. And even more challenging situation is that within a given season we are seeing all these things happening. In recent years we have seen in the same season, which is 120 days, you can see crops starting normally, then facing drought, and after some time facing flood, and then also facing heat. So that type of challenge becomes really difficult for us to handle. But of course, there are lots of opportunities there as well, but all of these require big capital investment. Okay, so again, I would say there are several options available to minimize impact of climate risk. I can't say that we can totally take care of all the risk, but we can minimize. One is, of course, forecasting, a big development here in this region in terms of how we use satellites and cell phones. I'll just show an example. A lot of progress in risk insurance, especially in India. In other parts of South Asia, this has not really progressed so well. But rapid payments, so assets are protected. I think that today roughly 30 million farmers in India are insured one way or other. Of course, it's a different issue that nobody is satisfied. In terms of weather-based agro-advisories, more than 3 million farmers. I think by today they were supposed to be reaching 10 million. So, and there are several technology practices like watershed management, conservation agriculture, laser leveling, which can help us in coping with extremes. And also very important, varieties of maize and rice which are more suited to some of this climatic risk like flood tolerance, drought tolerance are becoming more and more available. So there are several options that are there today, which let me again emphasize, which can help us minimize risk, not necessarily eliminate risk altogether, but again, to do that, there is a lot of capital, a lot of knowledge that is still needed for our farmers. Very quickly to illustrate some of these. So weather-based agro-advisory, this is happening very much in India these days. I know several other countries, Bangladesh, Nepal, Pakistan are also trying this, but it has been reasonably successful example here. It's a public-private partnership in the sense government departments provide forecasts, cell phone companies and ICT companies convert that to advisories to farmers and disseminate to cell phones. This is a model that's working reasonably well. Of course, again, there are several challenges, but that's a technology that's available and is scalable. Crop insurance, as I said, there are 30 million farmers already insured, and the potential is reaching 100 million farmers or even more. But what is very important, a recent study has shown, none of these 30 million farmers seems to be satisfied with this insurance scheme. No one is satisfied. What is even more ironical, the insurance companies who roll out these schemes, they are also not satisfied. And even worse, the government who subsidizes, that is also not satisfied. Huge amount of money, government subsidies going, So that is they are not happy. They are also not seeing the benefits reaching. Industry, which is supposed to make money but also ensure that farmers get the benefit, they are also not happy. And of course, farmers are also not happy. So why is it that the key reason is the dispute is how much is the loss? How do we assess what is the loss to individual farmer? I think that's a very big challenge. So what we are trying to do now is to develop some more innovative schemes that directly engage farming communities in measurement. Not only in measurement in designing insurance schemes, they should become responsible farming communities themselves in management, measurement, reporting and verification. And we use power of ICT tools, very simple GPS-enabled cameras which are low cost, and iPads that are becoming available to use some of these technologies to see how best we can increase the confidence of our people in this scheme. What is also very important, and this is again an area of research where we are investing a lot, that we don't want to see insurance as a standalone risk management strategy. Traditionally, we know several strategies are there. Water management in particular is critical and very important to build long-term resilience of the farming community. So we are working on better business models by which we can combine crop insurance and other risk management strategies. Okay, this is another important area which we believe is quite useful. There's a big emphasis these days on climate smart agriculture. I suppose all of you understand that. And that's what we are trying to see, how best we can again engage communities in managing resources better. So CCAPS has proposed a philosophy called climate smart villages, where communities are being mobilized to address their own issues. So we raise their capacity through two major interventions. One is climate smart technologies, which is again location specific. Farmers decide by themselves together with the local government and local knowledge experts that what is suitable for them. We use the power of information services. But all of these are linked to local knowledge and local plan. It's not that something is imposed externally altogether. So these are linked together with what is local knowledge, what institutions are existing there, and what is the village development plan. So all of these things are put together, not that we impose a technology which is just not gelling with the rest of the plan of the community. So this is a concept that we are trying in several parts of the world, also in South Asia, a lot of effort in India, in Nepal, and in Bangladesh as well. So several of our partners are trying to implement them, where the goal is not only intervention that lead to higher income, but long-term building resilience, adaptation, and mitigation. So what exactly we do in this, as I said, the first thing is participatory priority setting. So all stakeholders sit down together and set what are the priorities for them. And we distribute small amount of adapted seeds and get feedback, crowdsourcing sort of for evaluation, multiplication, dissemination of seeds. In fact, we are working on a system by which this crowdsourced information becomes useful for many other stakeholders. Water soil management, community insurance, ICT-based advisory, and so forth. So a number of interventions. This is a relatively recent effort which is happening in many parts of the world, as I said. Our initial experience suggests that in general the model is reasonably liked by farmers and also by other stakeholders. I'm very happy to announce here, for example, looking at this model, Government of Maharashtra, one of the states of India, has decided to scale out by themselves. So they're going to do it in 1,000 villages as a bigger pilot by themselves. I was wondering why I have been called here with the ESP meeting. What you pronounce it? ESPA? Okay, ESPA meeting. So then I went to the net and tried to find out what is ESPA. Well, I normally am not working on ecosystem services. Of course, when I was professor earlier, I used to teach some of these things. So I tried to see what are the ecosystem services that a typical climate smart village model that we talk about provides. I'm sure you can all agree or disagree with the definition of ecosystem services. That's your domain, so don't challenge me on that. Increased productivity is something that we always aim for. Increased resilience. So resilience again is a very contentious topic. How do we define resilience? For me at this stage is low variance of yield over different periods of climatic stresses. What we are also visualizing increased carbon storage. Firstly, because overall productivity goes up. There are more residues, and with conservation agriculture, you can rechannelize some of these residues back in soil. So overall, what we see, increased carbon, and of course, low GHG emissions. We are trying to use several interventions which will reduce emissions. Of course, most of the time, we don't design interventions there for emissions, but there are always lots of co-benefits. Increased biodiversity, there is a lot of research which shows that with conservation agriculture and with crop diversification that we are all promoting, biodiversity increases. And of course, many of the interventions result in conservation of water or increased water efficiency. Now, all of these we are trying to quantify for our climate smart villages. Besides this, many of the indicators are being monitored. Okay, so that brings me to the third point. Are we doing well with time? Okay. So exploit large mitigation co-benefits of several of these adaptation options. Now, mitigation in agriculture system is something not very much liked in this region. We don't want to talk too much because I don't want to get in the political space of discussion here. But there are lots of opportunities about adaptation, so why should we not focus on adaptation? But that's a different domain. But point is, all these adaptation strategies, by and large, whatever we say in the name of risk management, invariably they have some mitigation co-benefits. I think that's the way to address it, not mitigation-led adaptation, but adaptation-led mitigation with the co-benefits is something that we really have to understand and exploit to the best of capacity. Just to give you a brief overview, what is the, again, I'm using India as an example here because that's the data I had readily available. Today, 17% emissions come from agriculture. It's not a large emission. Relatively, of course, in absolute number, 17 is also large, but remember, 83 comes from other sources, right? And that's the real issue. Why should we really focus so much when it is only 17%? And why not focus on 83%? So these are some of the issues that we will not discuss here today, but those remain important. But nevertheless, in 17%, if you look at this part of the world, livestock, enteric fermentation is responsible for 2/3 of those. 2/3 of emissions come from livestock. A lot of people think paddy is the critical source of methane and other, but it's livestock which is so critical. 2/3. Paddy is only about 21% in this. 1/5 of agriculture emissions come from rice paddies, and soils, fertilizers are responsible for under 14%. And a relatively very small, negligible fraction from manure or from residue work. This is the current state of affairs about emissions. As I said, these numbers would change a little bit depending upon what country we're talking about, but by and large, that's the story in most of the South Asia. What is also very important for us to appreciate is a point that we are not often highlighted, a point again contributing to global debate, is in terms of emission intensity. So if you look at emission intensity, again this is a slide about India. So global warming potential, if you look over, this is a slide over time. I'm sorry, this is a little outdated, it's about 7-8 years old data. But what you see, global warming potential is going up because our food production is going up, our consumption of fertilizer and irrigation is also going up. So overall, global warming potential is going up. But what is very important, if you look per unit of food produced, this is going down continuously. And this is the normal today. Even if you look per unit of investment being made or per unit returns being harvested, this is significantly going down. That's what is very important. That's the point that we really need to maximize and do some sort of PR, that this region, emission intensities are significantly decreasing. It's not that they are increasing. So per unit, if you convert them to per unit food or per dollar invested, emissions are really going down very significantly. And in time to come, they will further go down. So again, as I said, several adaptation options are there, and many of them have large co-benefits in terms of mitigation. Paddy, we know we use a lot of water, so if we can increase water use efficiency, whatever means, for example, alternative wetting and drying, or direct seeding, they all lead to decreased emissions. Soils, increased fertilizer use efficiency, carbon sequestration. Livestock is a big challenge. It's not an easy one, but possibly there are some options if we manage livestock population better and feed management. Okay, moving towards the more or less last point. So this is something that I touched upon already, that there are some unexplored areas where we should think about what benefits climate change will bring to us. Right, so very quick summary. So why do we expect that to happen? What is happening is, if you look at mean changes in temperature, there is a shift in temperature zones. And that can often bring new opportunities. Crops which were not suitable are likely to become suitable. Some crops may not remain suitable. A very classical example is from hilly areas of India. I'm sure a similar example you can find from Nepal or Pakistan as well, is in terms of apple production. The last 20-25 years data, if you analyze, temperature in Himalayas have gone up by 1 to 1.5 degrees. And apple, which requires a critical chilling temperature to flower, that is not really being met for many of the current apple varieties. So what has happened, a lot of areas of Himalayas have not remained suitable for apples. As a result, farmers have to cut down apple trees there. So that's very well documented. But what is very important, areas at higher elevation, which were not suitable for apple, or perhaps not suitable for other orchard crops, have become suitable for apple. So farmers in that region have started growing apple. So that becomes an opportunity for them. Right? So that's reasonably well documented. So they have more income. And what is also important, areas where apples got vacated because they were not sustainable, farmers brought in vegetable cultivation, which became so suitable, and they are earning more money than what they were earning before with apples, right? So these are the opportunities that one has to really keep in mind and explore and exploit wherever possible. Of course, all of this is not simply temperature. You also have to see market conditions, other infrastructure that you really need with this. All climate change scenarios point out an absolute increase in precipitation in South Asia. Of course, there are spatial variation, but if I could just exaggerate a little bit, for all projections, practically all models, leave aside one or two, they indicate in time to come precipitation will increase. So on a positive side, you have more water. On a negative side, this increase in water comes in spurts. In spurts means it will bring more droughts and more floods. So that's a challenge, but absolute amount of water is more, so that's an opportunity. So if you can manage your water resources better, and there are lots of people here I know who are water experts, if you can manage that better, obviously that's an opportunity. But again, that has to be really analyzed, because everything that we talk about as cost, financial cost, institutional cost, and policy implication. Shorter crop durations. Increasing temperature reduces crop duration. So you often get a crop which is now 1 week shorter. Wheat, for example, in India, in northern India, is 1 week shorter in duration than what it was. And breeders, fortunately, have been able to encash that. Normally, you expect a reduced crop duration, crop yields will go down, but here that was not the case. So again, more time for using for something else. This is again very interesting. What we see similar situations, shorter life cycle of fish. Our scientists, fishery scientists here have documented that they're able to bring fish in the market much before than what they were able to do earlier. So which brings them higher price, right? So again, these are the areas which still need to be explored. They are very, very early studies, very preliminary studies, but while the negative consumer is something that we are always talking about, there are opportunities for all of us to, to discover, to elaborate, and to see whether they are business models in the future. My final point, which I would like to address, while technologically we believe we are empowered enough, yes, that given the right environment, given the right capital, right institution, and the right policy, we can do a lot for this region. But what is very important, the region is also plagued with several other issues. Poverty, human capital, literacy rates are still quite low. Governance issues, I think those of you who come from South Asia do understand this. Governance at all scales is still a big problem. Institutions are relatively weak. So these are the causes which limit to a large extent our agriculture growth today. I showed you we have all the potential, but we are not able to encash it to a large extent because of many of these factors as well. Besides capital, of course, is a major constant. So unless we address these things, whatever technological progress we make will never be sufficient. So we need to address all of these issues simultaneously, which is beyond perhaps agriculture scientists, but that's a larger issue that when you talk about ecosystem services, one has to internalize. I'll just give you a classical example of how things have been happening. So, but it's not that government agencies or organizational institutions don't do anything. This is a classical example of drought in India. We have, as I said, droughts all through. So this is 1877 onwards, the history of droughts. So every red dot is 1 million people died. Every blue dot is 50 million people affected. So what is very important for us to know, all these red dots which were in 1877 by and large have disappeared. People are not dying principally because of drought. Drought has been managed better compared to what it was. That's the time when 3 million people died. Remember, the population used to be much lower at that time. Now, but what we see is significant increase in people affected by droughts, mainly because our population has grown significantly since then. But what is also very important for us to realize, there have been several policy interventions every time a drought has taken place. So when 1877 drought took place, famine codes were established. Then in 65, we had this green revolution and creation of food corporations where food was stored, buffer stocks were made. So scarcity relief, then employment generation programs, drought relief, drought management, water management, and then more recently the knowledge management. So things are continuously happening. It's not that they're not happening. The only thing is, what they happen and when they happen, there's always some mismatch. These are all reactive policies. These are not anticipatory or preventive policy. I think that's one major problem that we have. We spend a lot of money, but do a lot, but most of the time that comes much later. And as I said, just to illustrate, despite all these policy responses, climate risks still remain a major source of worry for most of us. Again, my data is a little old. You see, because of widespread poverty, all these red areas, this huge part of South Asia are very poor people. Literacy rate, again, just as some indicators, remain very poor. So we need to address all of these issues simultaneously if we really want to make good progress. And of course, as I said, the governance remains a big issue. I don't think I need to elaborate. At all levels, that remains an issue for us to address. Okay, so that's the final part. I would say that overall what we need, increased investment in agriculture. And now we are talking much more about climate smart agriculture. And if that happens, this region, which is 1/4 of the world in terms of population, will stabilize much more, and that will ensure global equity and prosperity. Just to summarize, this is my last slide. I've tried to make 5 points that, of course, climate change is quite critical. I didn't go into scenarios because I suppose by now we all understand. it impacts food security. Climate has always been impacting food security at all levels, at local scale, as also national and global scale, and that will continue to remain critical. Increasing ozone concentration is something that we have not thought much about, but that has big consequences for large and populous regions such as South Asia, because whatever little benefits, whatever little compensation increased CO2 was providing can get easily nullified if this trajectory of ozone concentration increases. Increasing weather variability is something that we really need to be much more concerned about. We are also concerned about mean changes in temperature and rainfall, but even more important than that is weather variability. That's something that we really need to address today, tomorrow, and the day after. Our current vulnerability limits our adaptation in future. As I said, we are poor because of lots of reasons, and that limits our adaptation in South Asia, but also we can say for Sub-Saharan Africa. So there is a right technological mix available. Lots of other indicators are in favor, but what we still need is right incentive, right investment, right institutions, and right policies in order to encash all of this. That's where I would like to end. Thank you very much.